like what we did on our warm-up today. So if we're talking about integer exponents, that's basically just looking at an expression where there's some base. Whatever this item is, the big thing is the base. And then if it's raised to a power, that's your exponent. Most of you already know this terminology, but you just didn't realize that you knew it. You know what I mean? Brant actually used the term base already, which is kind of cool. And then the exponent, we already know what an exponent is. So really, like I said, not new, but I will be using this terminology a lot, especially when we're doing some properties and definitions and stuff. So I wanted to throw that out there at you guys. This is kind of a fun table. What I would like you to do is copy down this part of the table here. So you have your power and your value. And then I want you to copy down this part of the table. And you're going to see this pattern here. So if I have 5 times 5 times 5, that's 125, right? If I'm going to do 5 squared, well, then that's only 5 times 5, so I got rid of one of the 5s. Does that make sense? If I'm moving from left to right, right? As I'm moving from left to right, I'm getting rid of a 5, so that's why they're dividing by 5 to continue down the table. So what should 5 to the 0th power be? Ah, wait a minute. Look at the table again. Do you see what we're doing? We're dividing by 5. What's 5 divided by 5? This property right here is probably the most commonly mistaken property I see in Algebra 1 and Algebra 2. Anything to the 0th power is always 1 because you're taking your base and you're dividing it by itself. So then you should end up with 1. And then if we're going to continue this pattern of dividing by 5, right, to move to the right, what's 1 divided by 5? A lot of you think a negative exponent should make a negative number. So really what you are doing, 5 to the negative 1st power, if you just draw an arrow, 5 to the negative 1st becomes 1 over 5 to the 1st power, which is kind of cool, right? The way my predecessor, so Mrs. Bangle used to teach it, is she said, you got a negative attitude, you got to move it to the basement, right? You're going to go to the basement. So you got to go underneath that division sign. So anytime you have negative exponents, it doesn't necessarily make your answer negative. What it does, though, if we're going to divide by 5 again, I would get 1 over 25. Do you notice how these two things are very similar? 5 to the 2nd power, 5 to the negative 2nd power. It's what we call a reciprocal. They're the same thing, just flipped, right? So that negative exponent really just means that we're flipping that answer. So we're going to use this idea of 0 exponents and negative exponents. What I need you to write down, please don't write down all of this stuff. Anytime you have a 0 exponent, I'll box what you need to write. Anything to the 0th power gives me 1. That's all I need you to write. And then you can look at all of these examples, right? I could have x to the 0th power. I could have 3 to the 0th power, right? So any base, if it's raised to the 0th power, no matter what, it's going to become 1. Which I think is pretty cool. Kind of makes your life easy, right? You see that 0 exponent, boom, I know my answer, right? With your negative exponents, there is a property. It says any number, so x to the negative nth power. Remember, you got to move that negative attitude. We're going to go to the basement. You're going to be thinking about your negative attitude down in the basement down there. And then it moves, right? It flips your fraction in a way, right? So I want you to also write one other thing. What would happen if that negative attitude was in the basement? What should happen here? If I had a negative exponent in the bottom, using that same idea, you just flip it back. Yep. So it becomes x to the positive n. So instead of always moving it to the basement. If you're already in the basement and you got a negative attitude, we got to change that scenery, right? Maybe you need to go see the sunshine to change that attitude, right? So that's the idea of a negative exponent. It basically just, you got to move, right? You got to move to change that attitude, that negative attitude. So whatever that thing is with that negative exponent, it's got to move. And then, like I said, you can see some examples of this. So 3 to the negative second power becomes 1 over 3 to the second power, and 3 to the second power is 9, right? So we're going to practice some of this stuff. These are what story problems are going to look like on your homework. Really, all you need to know is, how do I simplify 2 to the negative fourth power? Well, I got that negative attitude, right? So I got to change that scenery. You're upstairs, you got to move to the basement. Think about what you've done. 2 to the fourth power is 2, 4, 8, and 16. And my units are gallons. This amount of work would get you full credit on a test. The nice thing about this chapter is sometimes there's not a ton of work you have to show. Some of you who are my anti-work people are going to love that. So same concept here. We can skip the next story problem, right? Let's work on simplifying a few more. 4 to the negative third power, that means I have to move that guy, change your attitude. 4 to the third power, we talked about this on our warm-up, that would be 64. 4 times 4 is 16. 16 times 4 is 64. 7 to the 0th power should be? 1. It's a hard instinct, right? You see the 0, you want 0, you think multiply. But anything to the 0th power is always going to be 1. It's a tricky concept to remember, right? Do you see why we went through our warm-up now? Do you see how C and D are exactly the same question? One has the negative in the parentheses, right? If I have negative 5 to the negative fourth power, well, I got to change the attitude of that negative exponent, right? I got to make that positive. But that doesn't change anything about my base, right? The only thing that's changing when I move something to the basement is that exponent. So I still have that negative 5 in the parentheses. So really what I have here is negative 5 times negative 5 times negative 5 times negative 5. Anybody know what negative 5 to the fourth power is? 5 times 5 is 25. 125. I'm going to cheat. It's actually, remember, it's somewhere back here. 5 to the fourth power is 625. And it should become positive, right? Because negative times a negative becomes positive. Negative times a negative becomes positive, right? That's different than this question. So I should get 1 over negative 5 to the fourth power, right? I changed that negative exponent to be a positive by moving it to the basement. This is really saying 1 over the negative and then times 5 to the fourth power, right? You can split up the negative and the 5 to the fourth power, so that negative is going to go straight to your answer. Remember that negative out front can go straight to your answer, and then you simplify the rest. A lot of people, when they see something like negative 5 to the negative fourth power, they write it like this to remind themselves that negative's got to stay way out front and it's being separated from the other stuff, right? And this is honestly the way I was taught it. Some people, they think that's more confusing, so you do what you need to do, right? We just talked about the negatives. Be careful. I don't know. I'm going to keep moving on. We've talked about this, right? We don't need to go through these examples, what to do with negative exponents. You got to move them, right? I feel like we've gone through enough of these. You guys remember these types of examples where it says evaluate the expression, which means you have to plug in the numbers? Let's go through a few of these, actually. Let's do 1, 2, and this one. We're going to do 3 of them. So remember, this word evaluate basically just means plug the number in and simplify it as far as you can, right? So there's two different ways to talk about this question. You could either simplify the exponent and then plug in the 4. Personally, I like to plug in the 4 and then simplify. So that's what I'm going to do. I would plug in 4 for x. And I have 4 to the negative second power. That 4's got a negative attitude, so we got to make it change scenery a little bit. So I would get 4 to the positive second power on the bottom in that basement. And 4 squared gives me 16. Does that make sense? Kind of? Ish? Okay. This next one, we have negative 2, a to the 0th power, b to the negative 4th power. Let's plug our stuff in. So I have a negative 2. And remember, a is 5. So we're going to get 5 to the 0 power. And then b is negative 3 to the negative 4th power. There's two things I need to simplify here, right? Anything to the 0th power gives me 1. And negative 2 times 1 is just negative 2, right? This is where we get a little bit confusing. Only we have that negative exponent, right? So we got to change the attitude. Only the item with the negative attitude is going to move. So that negative 2 is going to stay exactly where it is. And only that negative 3 to the negative 4th power is going to move. So I'm going to get negative 2 over negative 3 to the positive 4th power. Right? So remember, only the item with that negative attitude is going to move. Everything else stays where it is. And now we can simplify negative 3 to the 4th power. Well, negative 3 times negative 3 is positive 9. Times negative 3 is negative 27. Times negative 3 would be a positive 81. Right? And that's a lot of steps, right? This is about as far as you're going to have to go on a homework assignment. But it is important to recognize when you have to simplify more than one thing in an expression. So what I would like you to do is to answer this last one on your own. I want to check it, and then you guys can start your homework. It's only the odds. Okay? So I want to see what you guys come up with.